couple of entries. So we'd like to get more entries for the Tech Award. So check that out, everybody. Feel free to submit your project. We also have a newsletter going out tomorrow. In there, you'll see we have an ASHRAE Wisconsin YouTube channel. We've been uploading all of our meetings, past meetings. So feel free to check out that resource as well. Share with others. Let's see. For the newsletter going out tomorrow, if you guys have any updates, feel free to submit those. There should be some links in the newsletters. Let's see. For March 15th, we'll have 2 meetings in one day at HGA. So we'll have an email coming out for that later. One of them will be with the Wisconsin Crew, which is a real estate organization. So hopefully you can come attend and network with everybody. And then lastly, for updates, there'll be a DL evaluation form we'll post in the chat. So after the meeting, please fill those out for everybody. Haley will post those in the chat. So now we'll kind of get started in our presentation today. So today for our lecture, we have Terry L. Rogers. He's going to be presenting on managing building monitoring and control systems. So we asked Terry to join us. We wanted to get more controls meetings, controls lectures for our chapter. I feel like that's something we've kind of been lacking on. So thank you for Terry for coming to do this presentation. So a little background on Terry, I'll just read his bio here. So Terry has 40 years of experience in critical facilities operations and management, including planning, infrastructure design, operations and commissioning, building protection and recovery, preventative maintenance, and technical training and professional training development. Terry is an ASHRAE DL Distinguished Lecturer and a voting member of various ASHRAE committees, which revolve around critical facilities and data centers. So he has a lot of experience helping ASHRAE write those documents. He's on the board of directors for the 7x4 Exchange in Carolinas chapter. He's also on the board of directors of the Building Commissioning Association's Southeast region and has authored or co-authored books, white papers, and presentations on critical facilities, facilities management, and formal commissioning. He's developed and taught multiple training classes in design, construction, operation, and maintenance of critical facilities, including commercial nuclear power plants, aerospace facilities, and large data centers. So he has a lot of cool, interesting background. Terry has performed site reliability assessments for more than 50 sites in over 20 countries and 5 continents. He writes a bi-monthly column in Mission Critical magazine called Sustainable Operations. Terry is currently the VP and national leader for the Commissioning and Building Analytics Business Unit at Jones Lang LaSalle, or JLL. With that, I'll pass it off to Terry to start his presentation. Thank you, Terry.
Thank you, Gustavo. I appreciate the kind words and the opportunity to present today. Let me see if I can share my screen. So hopefully you can see my screen.
Yep.
Excellent. So today we're going to talk a little bit about managing building monitoring and control systems. So it's a DL lecture. The most important thing about this is, as I mentioned, please fill out the evaluation forms at the end of the presentation. Really value the feedback and it helps us improve. Perhaps the best and most important slide of the whole presentation is that ASHRAE is a volunteer organization. There are some paid bureaucracy, but the vast majority of the work is done by volunteers. We need you to get involved. There's various opportunities and committees and other aspects of ASHRAE that you can get involved with. It's a win-win-win because ASHRAE wins by getting their work done. The industry gets the standards and the guidelines it needs. You win as an individual because you network and meet people and get firsthand information up front. And your company and organizations benefit by having access to that information and the recognition that you're involved. Some quick learning objectives. We're going to list some big categories of monitoring and control systems, some challenges in deploying them, how monitoring differs from control, describe some alarm management, filtering, and escalation strategies. Talk about commissioning in general, and then how it's applied to commissioning of building automation systems, including the strategy behind commissioning, and then some challenges associated with that. So we'll talk about systems, deployment, controls versus monitoring, alarm management, pretty much what I just talked about here. So building, monitoring, and control systems are perhaps the most critical aspect of the infrastructure when you're looking at it from a facility management point of view. It gives the status of the building and the critical systems and how it's being operated. It can provide automation to protect the building when things go wrong, whether it's a utility outage or a piece of equipment fails, etc. And it's also a data processing and archiving tool, and can be used to, for troubleshooting and for optimizing energy efficiency and the performance of buildings. There's lots and lots of types of monitoring and control systems, and they bridge these categories. But in general, from what I've heard in the industry over the years, is you have the direct digital control systems, which are probably the most basic and most affordable and easiest to deploy. Then you get distributed control systems, followed by programmable logic controllers, which are sometimes embedded in that. And then the SCADA would be basically your industrial applications for large complexes with thousands, if not tens or hundreds of thousands of points. So DDC systems use a centralized controller approach. As I said, they're relatively simple. A lot of the devices and hardware are application specific and basically built to be used with a lot of the common infrastructure we encounter, like VAV boxes and air handling units, etc. Generally, they require the least amount of custom programming and setup, relatively inexpensive, and they're appropriate for a lot of infrastructure and typical office buildings, etc. Distributed control systems move the actual programming and logic and the sequence of operations and the actual commands, the control aspect, out into the field in field panels. So it's more robust and reliable from a hardened standpoint, ability to withstand problems and failures. But it's also a little bit more complex and a little more expensive, because you're now having more hardware and it's distributed. Typically, a lot of them have programmable logic controllers, and what this means is that there's less pre-programmed stuff, so somebody has to literally go in and do more customization and setup for site-specific conditions, etc. Less single points of failure, and so a single panel fails, you don't lose the whole system, and then it requires more hardware and field programming and customization than a DDC system, but it provides more functionality and capabilities. At the top end would be your system control and data acquisition system, SCADA. They're the most capable, scalable, and industrial of all the systems. They're able to manage vast amounts of data and traffic. They have archiving and other ways of compressing data, etc. Can be used for data mining, can span multiple buildings or even campuses. And of course, with the most functionality and capabilities, it also comes along with the most demands for customization and programming, and literally it's basically making the system do what it's intended to do. Most control systems will appear very similar to your operating staff. They have a front end and a command center or facility office where they can go and see screenshots, etc., the graphics. They have embedded points that you can drill down into. You can see status of stuff, et cetera. They have drill down menus, ability to trend and archive, et cetera. It doesn't matter. All of the, whether it's DDC or SCADA, to the front end, a lot of times they look very similar. What I've found is that all of these systems have enormous capabilities. They have modules you can usually buy. You have extra applications. They have the ability to do customized reporting. There's all kinds of stuff that they can do. But in a lot of cases, that's not realized in practice in the field. The capabilities are provided, but they're not taken advantage of. And why? Is because often the site doesn't have the in-house expertise to be able to take advantage of those types of capabilities, unless they happen to have somebody who's trained on the system to like the system administrator level and be able to do programming, add points, that type of stuff. Another aspect or strategy you use is then to purchase an installation contract. In that contract, to detail everything that you want out of the system, the types of reporting you want, all the ancillaries, anything that you want out of it. But again, this might help you get what you want up front, but if your needs change over time, if you don't have that system administrator and expertise in-house, then you're going to go house and have to buy it later. But in a lot of cases, you don't even realize that it's there and you've already bought it, you just haven't got access to it. What I see mostly in place are service level agreements where you actually contract out a maintenance and upkeep of the systems to a local controls vendor, typically the manufacturer's local rep. And then in this case, you have access to all that expertise, et cetera, but you have to pay for it on a monthly subscription, through an SLA of some sort. Control functions are mostly invisible, as you know, you can't see them. These things are black boxes, and within them resides the logic and the programming that recognizes through input what's happening in the field, and then sends commands out to control the equipment to make it do what we want, maintain temperatures, relative humidity, et cetera. And then, of course, when you have abnormal conditions, to like emergencies, to bring on redundant equipment, et cetera, and try to restore the systems back to normal. The key to stable and effective control is to have a comprehensive startup and testing and commissioning of the infrastructure, but also the controls that manage them. Systems and equipment testing, especially for your complex facilities, should be done at various load profiles if the building is going to experience various load profiles. So commercial office buildings, that's usually not the case. They're pretty stable. You load up the building with occupancy and it's pretty consistent over time. But data centers and some factories and other things can ramp up, ramp back down, or they can increase over time as loads added. And so a lot of times what happens is people come in and test it at the ultimate highest demand, the biggest load. And in reality, a lot of the control systems are most stable when they're under full load, like a chill water plant, et cetera. It's when you have a very low load condition, you can get the controls start searching and going into sine wave type things where they're going overshooting, undershooting, et cetera. So loop tuning is very important. But especially, some systems like chillers can become unstable at very, very low conditions, et cetera. So it's important to to test them at all ranges of expected conditions. An example here of a poor setup is VFDs. They're everywhere. They control fan speeds, pumps, et cetera. In one example, we had the fan ramp rate was faster than the ability of the VAV boxes downstream to open up. So when they started the system, it ramped the fans up faster than they could relief through the VAV boxes, and pressure it overpressurized the ductwork and basically blew the ducts up. Monitoring is probably the most visible aspect of the control systems and the most useful to the facility management staff, since it's assumed the systems are going to control. This is what they use to see how it's being controlled, stability, et cetera, on conditions. It's used to alert the staff of problems, et cetera. So typically, again, you have a front end at the central command center where you can see all of this stuff. But another capability that should be at least considered is the ability to connect laptops up to the field panels so that you can then gain insight and be able to view the screens, et cetera, in an equipment room where maybe critical activities are going. The command center should have, in my mind, as many displays as you can get in the room, basically. Today, displays are fairly inexpensive. The more information you can put up on the screens, the more information is then available to your staff, especially during an anomaly situation. Typically what I've seen is a minimum of 3 large screens and then a series of smaller ones. One screen could have the electric power, one the cooling plant, and one the area of interest, like a data center, computer room, or a factory assembly line, or a lab, whatever. And then you can use the multiple smaller screens to put alarm reports up, or to drill down to a specific piece of equipment, or for whatever you might need. Here's a picture of a typical command center. And as you see on the far left, we have a single line of the electrical distribution. The lines in red are active or hot. The other ones are de-energized. The screen in the middle has a chill water plant. And again, it's color coded between what's in use, and you have graphics that show which chillers are online at a given time. And then the screen on the far right could be used for whatever purpose that might come up. So switching gears a little bit, the facility management staff and the BMS basically support and complement each other and back each other up. It's important to understand that relationship if you really want to optimize the deployment and management of your BMS systems. The facility management team has oversight of the BMS in that they verify that the BMS is executing control properly and that the areas are stable and the conditions are correct. When they do command the BMS to do something like swap over a chiller lineup or something, a good strategy is to put staff at the BMS where they can initiate the actions and monitor on the screens what's occurring. Get staff actually at the chiller plant where they can physically verify that if the command is to open a valve, the valve actually opens, etc., and that the BMS is working correctly. And at the controlled environment, for instance, maybe in a data center, to make sure that you're not, during the transient of swapping the chillers over, that you're monitoring the critical space, et cetera. And of course, they also validate the accuracy of the BMS through routine calibrations and doing self-diagnostics through the BMS, and basically verifying that the BMS is performing as expected. On the other side, or the flip side, the BMS is providing some oversight of your facility management staff. It can ensure they're meeting service level agreement requirements. For instance, if it's a data center and you're required to provide ASHRAE recommended conditions at the inlet in the computer cold room, cold aisles, then the BMS can be used to monitor that over time and trend it, and then you can go back and prove that you were meeting your SLA. It can be used to track other key performance indicators like energy consumption and stable environmental conditions, et cetera. It can manage or oversee or report on the facility management responsiveness through incident and alarm logs. You can go back and see how many failures and problems you've been having, how many too hot, too cold calls or whatever, and other things through the BMS, and through alarm escalation. So it can actually report on how responsive the facility management staff is in responding to the anomalies. It can be used as a forensic tool when you do have an anomaly to go back and look at timestamps and sequences of actions that occurred, commands that were given, who logged on, logged off, all these other things can be reconstructed with timestamps so that you have an objective insight into the anomaly. If you do forensic investigations and you go out and interview people, it's not that they're trying to be deceitful, but their memories and their recollections are not always accurate, especially when it's a high tense and a stressful situation. So it's very helpful in that regard. And of course, to manage load profiles and transients, as I said, in data centers, as you bring more and more computer load into the room, you need to make sure that you're not exceeding capacities of equipment and losing redundancies, et cetera, and all that can be gleaned out of the BMS. So alarm management, not all alarms should be treated equally. And that's obvious. You could have a benign almost incidental alarm, and then you can have something like a secondary chill water high temperature, which means that you've lost your chiller plant and you're no longer cooling the load. So all alarms and anomalies should be captured at the front end, at the facility staff, and recorded, et cetera. Some alarms need to be distributed through remote enunciation, through cell phone or text pagers, whatever, to your roving staff. And then the alarms should be categorized by criticality, and those criticalities should also define who and gets notified of various issues. Non-critical alarms might just go to your on-site technician, so he knows there's a problem and he goes fixes it. Critical alarms could go not only to the technicians, but to facilities management, alerting to them that there's a bigger issue at stake. Extreme alarms could go to the technicians, the facility management, and other corporate management. And in my case, with data centers, it could include the NOC, or the Network Operations Center, or the IT command center. And then, of course, life safety and fire alarms could go to security and other people who have specialized duties to respond to that stuff. Alarm filtering is another capability most of these BMS systems have, but one that I see is often not taken advantage of. It takes some programming and some finesse on the people who set up and program these systems. But in some anomalies, especially like a data center, when you take a complete power outage to the building, you expect a lot of things to occur. You're going to have a lot of equipment fail from loss of power, and that's going to generate a lot of alarms. Then you're going to have a lot of activities in the electrical system as the UPSs are continuing to supply power, and the generators start, and the switchgear transfers over to generator power. And then you're going to see the chill water plant come back to life. And so now all these alerts coming in of equipment being restarted, et cetera. And the next thing you know, you've got a cascade of hundreds, if not thousands, of alarms that come rolling through, almost all of which are normal. It's what you would expect to occur with a power outage. What you want to do is filter out the normal stuff and find those that are saying something that was expected did not occur. A chiller that failed to restart, a generator breaker failed to close, so you're not getting power. And you don't want the staff to miss that or to have to go hunt and peck for it. So you want that to rise to the top of the alarm list, and you want to otherwise suppress the normal stuff. So alarm escalation. So another aspect of the BMS system is that if alarms are not acknowledged in a certain time, it could be 5 minutes, could be 15 minutes or whatever, depending on how you're staffing your site, then that should generate a second alarm that's escalated up saying nobody responded to this problem. So maybe the roving technician has forgotten his phone, or his phone has died, or for whatever reasons, nobody's gone and acknowledged the alarm. If it remains in alarm too long, it should be escalated up and then logged as something you can go back and look at. And then, of course, you have your nuisance alarms, So if something goes into alarm, gets acknowledged, an hour later it goes in alarm, gets acknowledged, and they just keep doing this and resetting it, that in and of itself should generate an alarm that says we have a problem that's recurring and needs to be addressed through a root cause or some other way of doing this. Another war story. This is a real life example where a secondary chill water pump was started and declared operational, but the BMS or BAS building automation system work was not complete on it. The pump was manually isolated to allow pipe installation work. The controls contractor later doing work ended up sending a command to start the pump that was isolated. The pump heat raised the water temperature to the boiling point because it had nowhere to go. It's not moving any flow. The pump's completely isolated. Eventually, it exceeded the boiling point, but because it had nowhere to expand, it just became a saturated steam type condition. Eventually, the pressure and the temperatures rose. And my guesstimation, I don't know, it was about 200 PSI or so because the pump was rated for 175 pounds. So I'm just taking a guess. That equates to about 380 degrees Fahrenheit water. So when it finally ruptured, we had what's called a boiling liquid evaporating vapor explosion, and a picture of the result is there on the right. What you see here is what's left of the pump volute. The hole here is where a suction diffuser, weighed 100 pounds, was thrown through the wall, knocked the computer room air conditioner off on the other side. This is where the motor had been bolted, sheared it completely off the base, through the motor about 30 feet, and it wasn't skidding along the floor because it hit a disconnect at about height of 3 feet. So it's quite a lot of energy that was released. This was only a 30 horsepower and 750 GPM pump, not a big deal. And then the steam blast going radially that wasn't blocked by the diffuser in one direction and the motor in the other literally blew the walls off the foundation. It was metal stud and drywall. It wasn't concrete or anything, but literally almost collapsed the room. So the forensics, we went back and found that the pump had been running for approximately 5 hours before it exploded. So there was a lot of BMS failures. There's some human error in this as well. But from a control standpoint, what happened was the pump was not taken out of rotation. It was just assigned to the last rotation. So we had 3 pumps and needed 1. So it was made the emergency pump. And then the BMS failed in that it was still working, but it was no longer sending remote annunciations out. So nobody knew that because they weren't paying attention and didn't realize they weren't getting any more remote annunciations. And then a flow meter failed. And in most cases, if the BMS had been set up correctly, a failed flow meter should have resulted in unreliable data and taken out of the algorithms and no longer included in the control sequence of operations. In this case, it was just reading 0 GPM. And so the system said, we need to start a second pump, and brought the lag pump on, and it still read 0 GPM. So it went to the emergency pump and called it on, and that's how this isolated pump that should never have been operating was commanded to run. And because you didn't have any remote annunciation, nobody realized it. It ran for 5 hours before it finally came unglued. So there's a lot of things that could have been done through the BMS that would have precluded this, and they were missed. So let's talk briefly about monitoring and control system maintenance and upkeep. Like all critical infrastructure, a BMS system, just like a chiller plant or anything else, it needs to have its own maintenance program. Generally, this requires skills and knowledge that is not typically in-house, unless you have a big operation where they've literally brought on a controls team and they have people who have that level of expertise. It should be part of a comprehensive maintenance program. So if you have a CMMS, a computerized maintenance management system, this should be included as just another asset and system. It should include things like doing software backups, archiving data, doing diagnostics, checking that basically the BMS system is healthy and performing well. I had an installation once and it was all commissioned, everything looked great. The system ran well, and then over time, it started to bog down. And I learned the difference between IP static and dynamic addresses, because it was supposed to have been configured with static addresses. So every time you brought on a device, it would have the same address, but it had been set up and configured for dynamic. So the old addresses still remained, as it kept adding new addresses every time a computer was logged back on, or a printer or a device in the field. The next thing you know, it's trying to communicate to the devices that didn't exist until it timed out and went to the next one and the next one, and it just bogged down till it basically killed the system. And it was back to it wasn't set up correctly at the first point, but it wasn't managed, and the oversight wasn't there to see the problems, which should have been identified by your controls contractor earlier, and not something that had to be brought to light by the facility management group, who's just noticing the system slowing down and not being responsive. So basically, you need to ensure there's calibration and sensors checked, but rather than that becomes overwhelming if you try to do it all in one shot, I say for all the calibration, and not all, the majority of your calibrations and sensor checks should be performed as part of the routine maintenance on a piece of equipment. So if you're going to look at a pump, make sure the pump's reporting correctly. If you look at a chiller, make sure that all the alarms and everything are done. And while you're doing these things, go out and calibrate those sensors, compare them to field measurements, and make sure everything's jives and is consistent. Again, it's best to have a service level contract if you don't have the in-house expertise to do this. When you develop a service level contract with a building management service provider, a controls vendor, there's certain things you want to include in that service level contract. The obvious one is the minimum response times. I have an anomaly. You have 15 minutes to call in and tell us what to do, and then you have 1 hour to get on site. If you can't resolve it on the phone, et cetera, or sometimes with response times that's appropriate. But also you want to make sure that whoever then shows up at your site has the necessary parts, tools, and meters to deal with it. So in a service level agreement, you can literally stipulate what products and materials and tools, et cetera, are in the van, what's available back at their local warehouse. And in one example, I actually carved out a piece of property in an equipment room, some space, had a chain link fence erected, and let the controls vendor have that where they could keep critical spare parts that I needed on my site, but I hadn't bought them, because a lot of times these things, it might be a year or two, or maybe who knows how long until you ever need a new field panel, et cetera. But I had it there in my site in case I needed it. Part of the agreement was if the controls contractor needed it for another site, they could basically steal it. It's theirs. They could take it away from me, but they had 24 hours or a week or some time period in which to refresh it and put it back in that cage, which covered most of my concerns with minimal cost. They basically, it was their stuff. I just allowed them to keep it on my site. And then things like software updates, diagnostics, data archiving, all that kind of stuff. It really needs to be done by people who have intimate knowledge of the system and how to do that type of stuff. So the best time to start managing the BMS is during the initial programming and design phase of a construction project. You want to define the BMS strategies and requirements and capabilities up front and have them formalized in the owner's project requirements document. You then want to ensure that the basis of design and the CDs that are developed by your engineer of record includes not just the products and hardware and the network and the physical system that they need to have installed, but also addresses the required training, procedures, commissioning, documentation, all the other aspects of what you're going to need over the long haul to maintain and manage the system. And this is, I think, pretty critical or important is that you really want to negotiate your service level agreements that you're going to utilize to maintain the system over the long haul up front. If you have these negotiations and conversations during the procurement phase, you'll find that your controls vendors and suppliers are very competitive and eager to offer up discounts on spare parts, reduce labor rates, all kinds of aspects of what you'll need. If you have that conversation after it's been purchased, and especially after it's been installed, your leverage is gone. It's not like you're going to rip out a BMS system and start over because somebody's charging you too much, you believe, for point adds and routine maintenance, et cetera. So if you consider it holistically up front in the programming phase, then you can negotiate these service level agreements in advance. And my recommendation is to go out at least, well, 5 years is good, at least 3 years. And the reason I say that is most of your customization, point adds, of repairs, or you name it, of changes will probably occur in the first several years of operation. And then it kind of levels out after that. And you're not going to get service level agreements beyond 5 years in most cases because nobody wants to commit but so far out in advance. So I'm a big proponent as an old operator on formalized standard operating procedures, which should include the normal, the maintenance, and emergency modes of operation of equipment. That includes chillers and generators and everything, but it also includes the BMS system itself. So I'm not talking about how you would use the BMS to rotate chillers or something of that sort so much as how do you manage the BMS system itself? How are software and firmware upgrades performed? And for instance, you definitely want to back up what you have before you go in and do a firmware in case it doesn't work, so you can back out and restore where you were. Things like archiving and system diagnostics and other types of maintenance level tasks for the BMS itself. You need to have procedures in place for that. A lot of times you need to have approvals. It has to be scheduled during the right windows. You need to ensure that you have the right training and technicians who are going to execute it. A lot of cases, you almost like a fire watch, you want to put people in strategic places when your BMS is either unreliable or down for maintenance, or they're reloading programming, or other things. You want to make sure you have procedures for gaining access to the BMS and who can get administrator or user, super user, or just view only rights, etc. Emergency procedures for a front end failure. What happens if the facility command center no longer can see the systems? So do you go out and establish, connectivity in the field? What happens if the field panels fail and now you've lost control and monitoring? So, how do you respond to that? And probably most importantly is procedures for how you operate the infrastructure manually when the controls fail, which really may not be a BMS specifically related procedure so much as having manual control of your infrastructure. But you don't want to do that on the fly. You want to ensure that when the BMS fails that you already know how to respond. And then the staff should be formally trained on using procedures, including drills and practice, and to ensure they're proficient so that they know how to respond when things happen. So some checks and balances. The facilities staff and the monitoring control systems complement each other, as I said. The effectiveness of each is kind of being overseen by each other. So the BMS oversees the facility management staff to some degree and vice versa. Best to have at least one in-house controls expert to oversee and manage the controls vendor service level agreement, if possible. Maybe overkill for a commercial office building who can simply call out if they have an issue. They have the luxury of being able to work on things on non-business hours without impact to the occupants, etc. But if you have any kind of real critical or complex infrastructure of a large nature, and you can justify it, it's a best practice to definitely have someone on your side who can manage the controls. I've seen a number of large data centers and other types of facilities who have robust IT networks within the facility who have actually brought the BMS network into their enterprise, into their actual data center operations. It'd be within a server in the data center. It'd be running through the data center switches and networks, et cetera. It's just carved out for the BMS systems. And so in that case, you might be able to leverage your own IT staff because they're already maintaining the switches, the servers, a lot of the hardware. Where they may not have the expertise without specific training would be on the BMS product itself. So one size does not fit all, and you have to basically pick the right strategy to match your needs. So now I'll switch gears again a little bit to talk about commissioning and then how that applies to monitoring and control systems. So at a very high level, a lot of people consider commissioning, unfortunately, after all this time, to be, we build it and we bring the commissioning agent in and he tests it. And that's not commissioning, that's what we call acceptance testing. Commissioning starts at the very beginning of a project in the programming phase. Per ASHRAE guideline 0, the commissioning agent should actually be the one who facilitates an owner's requirements workshop and then captures that in a formal document called the owner's project requirements. Then after the requirements have been established, ensures through the design phase that the engineer of record develops a basis of design and the construction documents and the sequence of operations to meet those requirements in the OPR. And then during the construction phase, through review of submittals and witnessing or reviewing factory witness and factory acceptance test reports, and then performing inspections during the construction, and then culminating with the startup and pre-functional testing of the equipment. We verify that what the engineer of record designed is being built. So again, it's a verification. Then you get to the acceptance testing phase where the infrastructure is built, it's energized, started up by the vendors and declared ready for operation. That's where the commissioning agent comes in and does the functional performance testing of all the equipment and the systems. And then that usually culminates in an integrated systems test, also called pull the plug test in some venues, where you literally hit the building with the worst anomalies that it's programmed to withstand, and see that the building automation systems and all the other systems react accordingly and protect the site, or at least restore it once power is restored, et cetera. Something that's sometimes overlooked as part of the commissioning scope is the training of your operations maintenance staff. Make sure they get the training they need. The best training they'll get is during the acceptance testing, where they actually witness the startup and the testing and the sequence of operations, the failure scenarios and all that. And then to document everything that's occurred in the project, starting through the OPR, the BOD, the CDs, the submittals, and all of your baseline test scripts, which is your baseline performance data, standard operating procedures, record drawings, all that kind of stuff. And most of that, if not all, should be crammed into a final commissioning report and delivered. And then, of course, maybe some deferred testing if necessary. If you think about that process, the whole strategy is to identify and resolve issues as early as possible when they would have the least impact on schedule, cost, and quality. So we identify faulty components prior to shipping, basically what makes sure stuff's good before it leaves the factory. We identify damaged deliveries prior to install, make sure that what you have has the right bells and whistles, it's the right configuration, you got all the manuals and everything upon receipt. So you don't find out that it's not what you expected when it's time to install and start it. Identify installation errors prior to startup. Identify system levels prior to going to integrated systems testing. And then, of course, the culmination of all the acceptance testing is to prove that the Bldg works before you turn it over to the owner for critical or for live operations. So the BAS system is absolutely critical to the commissioning of any building. The building automation system is critical because it actually controls the infrastructure. So especially during the level 4 and level 5 testing, the functional performance testing, we need the BAS system to execute the logic and the sequence of operations, but it's also a data collection tool. We use it to read the responses, the stability of systems to maintain conditions, etc. So it's critical. But that also means we need to commission the BAS first, prove that it's functioning correctly and that it's accurate and reliable before we use it as a commissioning tool, including executing sequence of operations or relying on the data that it collects. Which brings me to the critical path BAS challenge, building automation system challenge. So the BMS BAS systems design and installation is going to lag the other systems because you can't finish the design of the BAS until you know everything you're going to be controlling and you have all the sequence of operations. And the installation is contingent on completing the installation of the infrastructure and equipment because until you have an air handler to land wires on, you can't finish installing the BAS system, etc. And also during the startup, you can't really complete startup of the BAS system until you've started up the equipment it's going to be controlling. The equipment's gone live, it's got it's been energized, the panels are lit up, etc., and it can now communicate to and from the BAS system. But as I stated, you need to have the BAS system started and commissioned first. So the result of that is that the BAS system will always be critical path. I've been doing this for 40 years. I don't know of a project yet where, in some respect, the BAS system was a critical path item. So the challenge is how do you minimize that critical path? So the basic commissioning process applies to control systems, just like it would to a chiller or any other system. From an inspection perspective, these things are black boxes. So as a commissioning agent, I walk in the field, I can see the progress on the chiller installation, I can see conduit, I can see switch gear, I can see all this stuff. And I look at the BAS system and I see a panel, I see some wires running into it. I might even see a lights on or blinking, but from that's as far as I can tell looking at it. The sequences, the logic, the critically important stuff is software running inside that panel. So from an inspection perspective, I don't know if he's 10% done or 90% done just at looking at the panel. So again, we need to recognize that the design and installation are basically contingent on the infrastructure that you're going to monitor and control. And that the controls vendor is going to necessarily be waiting for some of these things beyond his control to get accomplished before he can finish his job. But there are things you can do to monitor the progress of your BMS vendor and make sure that he minimizes that window. So first of all, you want to make sure that you match the complexity and capabilities of the BMS to the capabilities and needs of the facility management staff. More is not always better. If you're not going to have a lot of expertise in-house and your needs are simple and basic, don't go buy a SCADA system that has all this customization, et cetera. And don't buy a bunch of extra modules and things that you're never going to need or use. So scale it to what your needs are. And then on the other hand, if you have greater needs than your facility management staff has expertise and capabilities to manage, then you need to invest in training and making sure that they get brought up to speed and get the tools and knowledge they need to be able to run those systems. Start managing the BMS as a critical path right from the very beginning. In the programming phase, you want to make sure that it's identified and communicated to in the CDs exactly how the BMS system is going to be managed. And one thing I highly recommend is what we call a BMS factory witness test. It's a bit of a misnomer because it's not like you're going to go back to the factory where the hardware is built. It's usually done at your local vendor rep's office, but he's going to have to build, configure, and put together a BAS system. If they do it in their office, then it's a clean environment. They can build all the panels, do everything. They're not out in the middle of a dirty construction site dealing with dust and other issues. They can link the panels and everything and actually build the system in their lab. And instead of 100 feet of cable between panels, it's 1 foot because the panels are sitting on side by side on a desk. But you can basically build that system. And there's really no extra effort because when it's built, you just literally relocate it into the field, hang it on the panels, replace the 1 foot cable with the 100 foot cables, and reactivate your system. By doing this, you can also require them to demonstrate to you the sequence of operations and the programming. They can show you the screenshots and the graphics that they built. They can basically demonstrate to you all of the stuff that you can't see by just looking at a panel in the field. And knowing that you're going to be looking at these milestones built into your schedule, they'll assign the staff and they'll do the work in advance. And if you don't do this in some manner or fashion, I have way too many times seen when I get called out in the field ready to do commissioning, the level 4 functional performance testing, and you get out there and there's temporary power and the guy's still trying to configure the systems, and there's all these hands in it, and it's very difficult to understand, and because you don't want somebody to go back and start playing with a system that you just finished commissioning and declaring was ready. So there's ways to minimize that critical path by basically riding roughshod over your controls vendor and making him report out on not just the installation of the hardware, but all the software and the soft skills that go behind that. Always require the BMS provider complete a point-by-point end-to-end verification as part of their level 3 startup activities. That should be included as part of the startup of a piece of equipment. So when the mechanical contractor goes out and starts up a new pump or an air handler, you need to make sure that the BAS is included as part of that startup, where they're comparing the field readings like a thermometer or a pressure gauge against what's being read back at the BMS system. The communication, the vendor lookup tables, all that is being completed. Often that doesn't occur, and we show up and they say, well, the air handler is ready to commission. We don't have any controls, but the air handler is finished. That's not exactly what we're expecting or looking for. And then require the BMS provider to participate during the commissioning in the startup of anything that he's going to be monitoring, whether it's a pump, a chiller, or whatever, that he's present during the functional performance testing in case something doesn't work right. He's there to help resolve issues, and also you're confirming that not only is the piece of equipment working, but it's reporting and being managed and monitored and controlled by the BMS correctly. And of course, for level 5 integrated systems testing, where the BMS is playing an integral role to basically managing the oversight of the responsiveness of the facility. And so that brings me to an end. I think we have a little time left for some questions and answers. Or hopefully I got answers. The answer might be I don't know, and I'll find out. But I'll do my best to answer anybody's questions. The presentation will be provided and will be available to you through your ASHRAE Wisconsin website after the fact, so you can go and see it. And for anybody who wasn't able to join today, you have my contact information there, including my email and phone number. I welcome follow-up comments or questions, inquiries, whatever. I'm passionate about this stuff and always welcome the opportunity to discuss it. So with that, I'm going to stop sharing my screen and hand it back to you, Gustavo.
Yeah, thank you, Terry. That was a really great presentation. Thank you so much for presenting to us. Does anybody have any questions? You can just speak up in the meeting here. If not, I've got two questions that came up. So commissioning the BAS system can be tough. What are some ASHRAE resources, or where can we find some ASHRAE resources to help us guide how to commission the BAS? A lot of things you spoke about, are there resources that ASHRAE offers to look this up?
Yes, and I apologize. I should have had a slide in here that lists all of the ASHRAE committees and guidelines regarding commissioning, because a lot of that is addressing the BAS systems. But from a commissioning standpoint, ASHRAE is a leader in the commissioning arena. Even the Building Commissioning Association liaisons with ASHRAE committees. They recognize that the ASHRAE has a standard 202, which is the commissioning process, which is what I would call a minimum requirements document. Being a standard, you have to do at least this in order to meet the standard. Mm-hmm. And then you have ASHRAE Guideline 0, which I would call a best practice document. As a guideline, it's not written as enforceable language, etc., but it covers everything that you can and should do as a best practice. So they're complementary to each other. They just have a little bit different perspective. They're carving out what I would call sister documents for use with those, meaning that there's one like for how you apply the generic commissioning process as described in Guideline 0 to HVAC and R, which is of course ASHRAE's domain. But rather than rebuild the whole guideline, they basically, it's supposed to be used in concert with Guideline 0. They have one on systems operations and maintenance manuals, one on operators training, and we're developing a new guideline for applying the commissioning process to data centers. And data centers are somewhat different from commercial office buildings. Yeah. And probably 50% of the activity in a data center is electrical versus in a commercial office building, it's almost vastly HVAC and mechanical stuff. And then a lot of other nuances that go along with data centers. So there's a lot of information available through ASHRAE. I could follow up if somebody or whoever wants me to follow up, send me an email and I will send you that type of information. I apologize for not having that.
Oh, no problem, no problem. I guess the other question is too, it sounds like you've written a lot of articles and some technical papers. Where can they find your articles? Can they email you, or do you have like a website or your chapters page?
So you can email me and I would be more than happy to help in that regard. I've written 47 articles now with Mission Critical Magazine, which covers pretty much everything I can think of.
Okay.
I haven't written an article in about a year because I literally ran out of topics and we had a pandemic and I changed jobs and all the other things. But basically, I cover a whole lot of different things gleaned from 40 years of being in the business. If you go to Mission Critical Magazine, Google that. I think it's missioncriticalmagazine.org. Anyway, you can get to my column, and you have to register, but it's free. So just go online, register, and then you can get you can get the virtual subscription, electronic subscription for free, and you can get in there and there's lots of good information. I'm just one of many people who contribute to that. I have other, the ASHRAE Datacom book series is available for purchase through ASHRAE Bookstore. The BCA has enormous amounts of information, so if you're not a member, join. It's reasonable cost. They have various levels for like the corporate and students and whatever, but it will give you access to commissioning best practices, to sample scripts, to ways to write RFPs to get good commissioning, I mean, there's a whole wealth of data and information available in the BCA. 7x24 is another organization, but that's pretty much the data center, you know, the never fail, never shut down type of industries.
Yeah.
So I would welcome, send me an email and I will do everything I can. And if you target me what you're looking for, I can help in that regard as well.
Awesome. Thank you. Thank you. One other question that came up here, I'll just read it. Do you have any pros and cons for building owners considering BAS monitoring through a vendor that offers software as a service?
So that's a pretty good question. I may not have the best answer. What I would say though is that in my experience, and this is my personal opinion, okay, this is not an ASHRAE or anybody else, this is Terry Rogers, is that most of these monitoring and control products are extremely robust, very reliable, very similar in capabilities. They're really good products and they're very similar. So what really differentiates to me is the technical backup and responsiveness of the vendors you're going to rely on after you've purchased and installed it. And so if you've got a choice between manufacturers and one is local office is 4 hours away and one of them is 4 minutes away, well, that's a differentiator.
Mm-hmm.
If one of them is willing to provide a service level agreement that includes all of the things we talked about at a very reasonable rate versus somebody who doesn't want to negotiate and is going to hold the line, that's a big differentiator. If you've had good experiences and a trusted relationship with a vendor, that's very important. So I guess what I'm saying is that the technical capabilities and the quality of the hardware and products to me is very similar. I'm not saying that a SCADA system and a DDC system are the same, but I'm saying any DDC system from the various manufacturers are going to be relatively similar and of similar quality. It's the responsiveness, the trust, and what you need from the vendor for the long-term haul that is going to differentiate one vendor from the other.
Awesome. Awesome. Thank you. That's good feedback. Does anybody else have any questions? Yeah, so I think that's all we have here, Terry.
So software as a service, I didn't really hit that because I'm not real savvy on it, but I would say that that rolls into that service level agreement type of a, I would never outsource I would never put my BMS in the cloud. I've never heard of that. I don't know if anybody's ever done that. I'm not even sure that's a possibility. But you don't want your software out of your control. You want to own it, you know, through a license or whatever. You want to own your data. Most of my clients don't want even the BMS archive data in the cloud. It's too proprietary. It's too important. So they keep it in-house. They keep it in their possession, whether it's in their own data center or wherever. But I'm not really aware of software as a service really in the BMS world as I see it in the IT world.
Okay. Yeah, Brant Holman mentioned Train SC Connect. I'm not too sure on if that's software as a service. But no, that's good.
Well, I will kind of make an analogy here is that there's another presentation I give called Complexity versus Reliability. And the central message is that keep it simple sometimes is the most reliable way to go. And another message there is that over the decades, vendors, including BMS people, are continually trying to one-up their competition by adding the next ancillary and the next bell and the next capability and the next thing, whatever, the next improvement. most energy efficient, you name it. And they've taken things like a fan coil, and now you go into a menu and there's 6 sub-menus below it, and there's about 1,000 configurations, and there's all this stuff, and it's still just a fan coil. So if you need 100 different configurations, go buy them. But if you're just going to run an air handler, you don't need all that stuff, right?
Exactly.
And then the next thing you know is you've bought complexity that your facility management staff can't manage. And the next thing you know, you go out there and the stuff's running in hand because they didn't know how to fix it. They didn't have a server level agreement, and it was just too complex. They didn't know what to do. And that's a detriment because you've spent a lot of effort and money to get capabilities that you never get the advantage of. So I just be careful about the next new thing.
Mm-hmm.
And if you need it and it's available, use it. But if it's just new stuff for the sake of new stuff, just be careful about that.
Awesome. Thank you, Terry. So I think that's want to be respectful of everybody's time here. I think that's all we have. But thank you for the presentation. We really appreciate it. This was a really good one. Thank you.
My pleasure. And again, please fill out the evaluation forms. That's the only way I figure out how I'm doing. And allows me to improve.
Yep, everyone, those are in the chat. Yep, please fill those out. And then also, I'll just I can let you go, Terry, if you gotta run.
I have
but
a call I gotta get on. All right,
awesome.
thank you all.
Thank you. So everybody, I just want to give you an update of a couple little updates here. I'll share my screen. So we've got a new ASHRAE website, just in case you haven't known, the name has changed. So it's ashraewisconsin.com. So feel free to log in, check it out. We'll be posting our events here. We lost access to our old website, so just be aware the name has changed. We have the Tech Awards coming up, so check that out. There's a whole page on here for awards. Those are due by April 8th. So in past years, we've only had a few submissions. So we'd like to try to get more submissions this year. So feel free to go check this out for more information on the website. Our newsletter is going out tomorrow. So if you guys ever have any articles or any input on the newsletters, feel free to reach out to us. We also have an ASHRAE YouTube channel called ASHRAE Wisconsin. We'll be posting all of these recorded meetings on there. So feel free to check that out. And then we'll also send out a meeting invite for next month's meeting on March 15th. That'll be 2 meetings in one day. One of them will be with an organization called W-Crew, Wisconsin Crew. So they're a real estate organization. That'll be at HGA. So feel free to come by, have some lunch, and network with everybody. So I think that's all I have for updates. And let everybody go.
Thank you.